I'll be walking through the HFSS tutorial for the horn antenna as well as the horn-fed reflector antenna. You want to launch Ansys Electronics, and then you want to go to Tools, Options, General, go to HFSS, Boundary Assignment, make sure all are clicked. "3D Modeler", History Tree, make sure all are clicked. Rendering set to 0.7. In Drawing, make sure that you're allowed to edit properties of new primitives. Checked. We'll do a new project. We'll insert an HFSS design. Then we'll set the solution type to HFSS with hybrid network modal. Okay. Next we'll set the units, inches. Make sure the default is vacuum. The default material is vacuum. Now we will go about drawing the actual horn antenna. So we'll place a box randomly first, and then we'll go and set the values. Horn length minus A over 2 minus B over 2. Horn length will be 5.2 inches. A will be 0.9 inches. B will be 0.4 inches. We'll set Y size, X size to WG length at 1 inch. We'll set Y size to A and Z size to B. And now you'll get a box that's offset from the origin. And if you want to see the origin, there it is. This is the back end of the horn antenna. Next, we want to draw the front end of the horn antenna. So we'll draw in, we'll draw in a rectangle, but we want the YZ plane. So we'll go to Modeler, Grid Plane, YZ. Then we'll draw a rectangle randomly, and then I will set the values as 0 minus flare A over 2 minus flare B over 2. So flare A will be 2.65 inches. Flare B will be 1.95 inches. The Y size will be flare A, and the Z size will be flare B. Apply. Okay. So this is the front, and this is the back. Next, we need to create a face object. So we'll go to selection mode, set it to faces. Then I'll select this face, and then modeler. No, draw. Create object from face. Surface. modeler surface, create object from face. Now we have an object here and an object here. We can use the sweep function to join them. So you want to select this object, hold Control and select this object, and then if you go to Modeler, Surface, and Connect, you'll get a sweep between the two objects. Now we want to unite these. Make sure you go and switch from selection mode faces to selection mode objects, and then you're going to go select both of these and then modeler boolean unite. Okay, so now it's all one object. Then we'll go back to selecting faces. We want to select every face except for the front face of the horn. Make sure they're all selected, except for the front face of the horn. Now with everything selected, you want to go to Surface, Modeler, Surface, Create Object from Face, and then everything is still selected. You want to go to Modeler, Boolean, Unite. Now you have one object that has the shape of the horn, and all we're going to do is add some thickness. So we'll go to Modeler, Surface, Thicken Sheet. We'll set the sheet thickness to 0.05 inches. Okay. Now this is looking like a horn antenna. We can take the previous object and rename it to air. Okay. We can take the new object and rename it to horn. There. And then we just need to draw an air box, so we'll do draw, region, pad similarly, absolute offset, and we'll do rad underscore dist, setting that to 0.4 inches. Okay, there's our box. We're going to apply a boundary to this region, so we'll right click, assign boundary, assign hybrid, and we're going to assign FEBI. Okay. Now if you go to your window here, you'll see that you see FEBI there. Next, we want to set up a port. Before we do that, let's turn the horn into a perfect electric conductor. So we'll go to Edit, find PEC here, perfect electric conductor, and apply that. Okay, so now you see the material of the horn is PEC, and the vacuum is for air, and the air box around the antenna. Now we want to set up the wave port. So we'll go to set our grid plane, make sure it's in the YZ direction, it still is, so we'll go ahead and draw a random rectangle, and we will assign the values as horn length plus WG length, waveguide length, and minus A over 2, minus B over 2, and we'll set the Y size to be A, and the Z size to be B. Apply that, and you see it's nicely set there at the back of the horn. Next, we want to assign an excitation to this wave port, so we'll do excitation port wave port. 1 is fine. We'll do a new line. You can set it from the top to the bottom. And do next. Finish. Alright, next we're going to save this as a 3D component. So first save the object here, and then go to Edit, select Objects by Name, select Horn Air Rectangle. Okay. Horn, air, and rectangle. Okay. And then we'll go to Draw, 3D Component Library, Create 3D Component. So this will allow us to export this as a 3D component that we can then import into other projects. So we'll go to our new folder here, and we'll call this Horn Parametrized. Save. Or also horn without airbox, that's fine as well. Next, we'll save one with the FEVI boundary. So we'll go ahead and do Control All, or rather, I'll select this, hold Control, and select every item. We want the region and also the wave port, and then Draw, 3D Component, Create 3D Component. Okay. And we're going to save this as Horn FEBI boundary. Okay, saved. Next we're going to go ahead and model the reflector, so we'll just go File, New project there, insert an HFSS project, make sure that you change the solution type again to HFSS with hybrid and arrays, network modal. So you want to see that there. Then make sure you set the modeler unit to be inches. Okay, that's good. And then we'll go ahead and save this as reflector. And now we can add some design properties. Design properties, add. First one is going to be focus. Set that to be 10. Do not add units here. We're going to add units in the definition of the equation of the curve of the parabola. So if you add units here, it will change the size of your resulting shape. So if we go ahead and look at the properties here, now they're there. Okay, so now we can use them in our equation. So we'll go to Draw, equation-based curve, set this to 0, and for y we'll do underscore t times 1 inch, and we will do focus minus underscore t minus underscore t times underscore t divided by 4 times the focus, close the parentheses, and multiply by minus 1 inch. For our start t, we'll do 0. For our end t, we'll do ref grade and 0 points. Okay. And there you see the curve. Now what we're going to do is sweep this around the z-axis and create our nice parabolic reflector. So we'll select it, we'll go to draw, sweep, around axis, z, and set it. So now you have this parabolic reflector. You can see by the scale, I'll set this, you can see by the scale it's about 20 inches wide. Makes sense because our antenna is about 5 inches long. So go ahead and save that, and now we're going to export it after we assign the material to be PEC. But because it's a sheet, we're actually going to assign a boundary. So assign boundary, perfect E. Okay. And we actually need to assign another boundary, assign hybrid IE region. Okay. And then we're going to go HFSS, mesh operation, apply curvilinear. Let's see if we can go through here. HFSS, mesh, initial mesh settings, and then click this, apply curvilinear meshing to all curved surfaces. Click OK. So we can save this, can rename this thing as Reflector, and now let's go ahead and export it as an object. So I'll select it, go to Draw, 3D Component Library, create 3D component, just check out the model, the boundaries, no excitations, there's a hybrid, click OK. Reflector IE. Save that. Okay. Next we'll do an analysis on the horn antenna. New project. Gonna insert an HFSS design. We're gonna again set this to be network modal. For this one it doesn't have to be hybrid, but network modal. And then let's just double check that the units are correct. Inches. Okay. Let's now insert our horn antenna. So we'll go to Draw, 3D Component, Browse. We want horn parametrized with no airbox. Click OK. You can just bring it in as it is, and then do Edit, Arrange, Rotate, -90 about the y-axis. Okay. So our antenna is actually facing the -z direction. Let's add an analysis and then a radiation setup, as well as an open region. HFSS, model, create open region. Operating frequency 10 gigahertz, just radiation. Click OK. automatically created here. Now we're going to go insert far field setup, infinite sphere, set this from 0 to 90, steps of 2, from 0 to 180, steps of 2, click OK. Now let's add a solution setup. Add solution setup advanced. We'll do single at 10 gigahertz. OK. And we'll click OK. And then let's disable the sweep for the initial run. So we're just going to solve at 10 gigahertz. Validation check. Looks fine. Analyze all. We'll save this as horn analysis. Alright, looks like the analysis has finished. Let's go ahead and view our far fields report, 3D polar plot. We'll do directivity, total, in dB. New report. Oh, we actually want to use the infinite sphere, so let's do a new report. Okay, there we go. So we just tested for 1/4 of the pattern at 10 gigahertz. And we see that here. So we have 1/4 of the pattern. This looks reasonable for a horn antenna. There's a side lobe and a main lobe. The total gain is about 16 dB, so that's fairly typical. So this looks good. Now let's simulate the horn-fed reflector antenna. So we'll open a new project. Go to File, New, insert HFSS, and this time we want to change the solution type to HFSS with hybrid and arrays, network modal. Okay. Let's check the units, set that to inches. And then let's go ahead and insert our components. We will browse for first the horn with the boundary. We'll bring that in. We're going to set the radiation distance to be 0.3 inches. Okay. And then we're going to go to our 3D component library again and bring the reflector in. So we'll bring the reflector in, but we want a radius of 6. So focus 10, radius 6. Okay. Now we're going to rotate our horn. Select the horn submodel, go to Edit, Arrange, Rotate. As before, we'll do -90 about the y-axis and leave it there. Now we want to put the reflector on its own coordinate system so that we can move it parametrically and study the effect on the radiation pattern. This is not necessary for this video tutorial, but will be helpful for in general. Okay, select away. Modeler. Hold Z. Now we have a new coordinate axis. We're going to go find it here. And then we are going to modify this and set its position to minus offset. We'll set offset to 0 inches. Alright, apply. So now the relative CS and the original coordinate system actually line up, but that's not necessarily true. If you change offset, you can get it to move. So now let's set the reflector submodel to be dependent on that new axis. Let's see. Properties. Let's get properties here. So we got the reflector now, and we'll set the target coordinate to relative CS. So I'm going to leave it for the simulation, but if I set this to 1 inch, you can see that the reflector moves away by that amount. And by doing this, you can study the effect of the distance of the reflector from the horn. Okay, so set it to 0, and we leave this. Now let's add an analysis. Advanced. We want 10 gigahertz. 1 pass. Okay, and we want no sweep to get started. We'll also run a validation check. Okay, we have a boundaries error. Let's see. Excitation must be defined. Okay, this should have an excitation. Let's see. Okay, it's missing its excitation. So I'm going to go into the project with the horn. And go ahead and save this again. Where's the project with the horn? This is the project with the horn. I'll find the horn, the air, the rectangle waveport, I guess, as well as the region, and do modeler, no, draw 3D component, create 3D component, okay, and I'll save it with as horn FEBI boundary V2. Okay. Now I'll go back to the project. I'll save this as the reflector antenna analysis, and I'll go back into here, and I will replace this object with the one that we just saved. And we will take the okay, so we've deleted the horn now. Now I'll go and insert the horn again. So I'll go to modeler, browse. I would like the V2. Set this to 0.3. Edit, arrange, rotate. This is already set correctly. go ahead and do this, and now we'll just do a validation check. Select objects by name. Select all 4 of these. Okay. Okay. Go ahead and select these again. Let's make sure it's getting exported. Excitation, we've got to wait for it. Okay. And we'll do V3. So, we'll go back to the analysis here. I need this one. I will delete this object. And then I will insert a new object, browse, V3, 0.3, okay. Let's run our validation check again. Alright, this time we pass. Now we'll analyze everything. We're just doing an analysis at 1 frequency, so we can get a sense of the fields on the reflector at that frequency. Okay, looks like the simulation has finished. Let's do some field overlays. I'll select the reflector face and then plot fields. Let's plot J mag surf on the surface of the reflector. Done. Okay. There you see the surface current. We can do another one. E mag E. E. Okay, done. Now you see it. So that's pretty reasonable. That's also pretty reasonable. And we'll save those. Then we can add a far field setup. Just have a look at the radiation pattern. Results, far field report, 3D polar. Gain is fine. We'll put it in dB. The report. And this is the type of shape you get. Okay, that wraps up the tutorial on the horn and reflector antenna. Thanks.